is Advanced Algebra 1, looking at Topic 6, Section 4, geometric sequences. So we've already learned when we were learning about linear equations, lines, we studied arithmetic sequences and learned how to write a recursive definition. We learned how to write an explicit formula for those. And so now that we're studying exponential functions, we can move on to geometric sequences because they are exponential. If you add something and you add the same thing over and over and over, like 1, 3, 5, 7, 9, 11, that's arithmetic. And, add 2, add 2, add 2, add 2, add 2, or you could subtract the same thing over and over and over. And either way, it's an arithmetic sequence, and it's of the form, f of x equals, I'm sorry, the wrong notation. How about a of n equals a sub 1 plus d times the quantity n minus 1, and that would get us the explicit formula. So if I wanted to know the 100th term, I would plug in 100 for n and figure out what the 100th term of the sequence is. In a geometric sequence, you multiply by the same thing over and over and over. So when we were looking at, you start with $1, and then you have $2, and then you have $4, and then you have $8, and then you have $16, and then you have $32, and then you have $64. That's exponential. And if I want to know how much money I'm going to have on the 30th day, I have 2 to the 30th dollars. Okay? So if you multiply by the same thing, multiply by 2, multiply by 2, multiply by 2, multiply by 2, or it could be multiplied by a half, or it could be multiplied by -3. But if you have something like that, then it's a geometric sequence. And the way that we tell is you take the term and you divide by the previous term. So if I take 4.5 divided by 3, and then I take 6 divided by 4.5, and then I take 7.5 divided by 6, do I get the same thing each time? I don't know. Let's see. So 4.5 divided by 3 is 1.5. 6 divided by 4.5 is not the same thing. 7.5 divided by 6 is not the same thing. So this is not geometric. If you look at it, if I add 1.5, and then I add 1.5, and then I add 1.5, and then I add 1.5, I get the next number. So not geometric, it is arithmetic. And the common difference is 1.5, because that's what I'm adding each time. Okay, so let's look at the next example. We start out with 3, and then we have 2. So you take the previous term, you take the term and divide by the previous term. So 2 divided by 3, and then 4/3 divided by 2. Let's see. 4, no, that's not what I want. 4/3 divided by 2 is 2/3. So that was the same. 8/9 divided by 4/3. Let's try that one. So 8/9 divided by 4/3 is 2/3, the same thing. So this is geometric. And the common ratio is 2/3, because that's what I get when I divide. Okay? 75 divided by 1 is 75. 149 divided by 75 is not 75. But 1 plus 74 is 75. And then if I add 74 again, I get 149. And if I add 74 again, I get 223. And if I add 74 again, I get, so this is arithmetic. And the common difference is 74. And the common difference for arithmetic, we call that D. The common ratio for geometric, we're going to call that R. Okay. So if this next one is geometric, it means that when I divide by 2, when I take 2.2 divided by 1, 2.2 divided by 1, I get 2.2. 4.84 divided by 2.2 is 2.2. 10.648 divided by 4.84 is 2.2. So I get the same thing each time. This is geometric. And the common ratio, we use R for the common ratio. The common ratio is 2.2. All right. So for a geometric sequence, the recursive formula, A sub n, excuse me, A sub n equals R times the quantity A sub n minus 1. So to find the next term, you multiply the previous term by the common ratio. Write the recursive formula for the geometric sequence 8, 12, 18, 27, 40.5. So first we find the common ratio. We take 12 divided by 8, and we get 12 divided by 8, and we get 3/2. And we take 18 divided by 12, and we get 3/2. So the common ratio R is 3/2. So the recursive formula A sub n equals R, which is 3/2, times A sub n minus 1, and then we have to say, remember that for the recursive formula, we have to say what the first term is, so we know where to start. Okay, so this whole thing would be our recursive formula. Okay, write the recursive formula for the geometric sequence, and this one's, R is going to be a fraction. 768 divided by 3072 is 1/4. So R is 1/4. So the recursive formula, A sub n equals 1/4 times A sub n minus 1, and A sub 1 equals 3072. The explicit formula for a geometric sequence. Explicit formula is A sub n equals A sub 1 times R, which is the common ratio, to the n minus 1. So write the explicit formula for a geometric sequence whose initial condition is 3. So that's A sub 1. And the recursive formula is A sub n equals 6 times A sub n minus 1. So that means that the common ratio is 6. So the first the first explicit formula a sub n equals the first term, or I'm sorry, the first term, which is 3, times the common ratio, which is 6, to the n minus 1. And when we get into pre-calculus, we'll actually simplify that expression. I don't think they're going to ask you to simplify that in this class, but there's a way to simplify it, and we'll just leave it at that. The next one, and next example, right? The explicit formula for the geometric sequence described below. So let's see. The first term is 2, and the common ratio, 6 divided by 2 is 3, 18 divided by 6 is 3, 54 divided by 18 is 3. So a sub 1 is 2, and the common ratio is 3. So the explicit formula, a sub n equals the common ratio times, I'm sorry, does not equal the common ratio. It equals the first term, which is 2, times the common ratio to the n minus 1 power. And remember, as I said on the front page of the notes, that what the explicit formula does for us, if I want to know the 50th term in this sequence, I would take 2 times 3 to the 50 minus 1, or 2 times 3 to the 49th power. And we get a humongous number, 4.7859 times 10 to the 23rd, somewhere in there. So it's a pretty big number. This is growing pretty quickly. Exponentially, in fact. No pun intended there. Okay, in the first week, there were 5 subscribers to a blog, and the number of subscribers doubles each week. So 5 and 10, 20, 40, 80, 160, da 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 da. First thing we ask, is it arithmetic? Well, let's see. Add 10, add 10, add 20. Or I'm sorry, add 5, add 10, add 20, add 40, add 8. No, it's not arithmetic. Is it geometric? Well, 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. What do you... Sorry. 160 divided by 80 is 2. So it is geometric. So how can the trend in the subscribers be modeled? It can be modeled as a geometric sequence. And we can write the explicit formula, a sub n equals r equals, for some reason I want to put that r in there too soon, equals a sub 1 times r to the n minus 1. So for this particular one, a sub 1 is 5, and the common ratio is 2 to the n minus 1. And we've been putting that in parentheses. So if I wanted to know how many subscribers there would be at the end of 4, 5, 6 weeks, I would plug in 6 for n. Could also write the recursive formula for that, which is, which would be a sub n equals common ratio, which is 2, times a sub n minus 1, where a sub 1 is 5. So there's the explicit formula, there's the recursive formula. Okay. Last page. All right. It says write an explicit formula for each sequence represented by the recursive formula. Okay, so here's a recursive formula. I start with 100, and then I multiply that by 4/5. I get 80. Multiply that by 4/5. And I get 64. And then multiply that by 4/5. And I get 256 over 5. And I'm going to quit there. And we're supposed to write an explicit formula. So explicit formula, a sub n equals a sub 1 times r to the n minus 1. So for this problem, a sub n equals the first term, which is 100, times r, which is 4/5, to the n minus 1. Okay. And we have, write the recursive formula for the sequence represented by the explicit formula. So in this explicit formula, the first term is 0.4. The next term, I would multiply that by 8 and get 3.2. Multiply that by 8 and get 25.6. Multiply that by 8 and get 204.8, and so on. So the recursive formula, a sub n equals the common ratio times a sub n minus 1. And then I have to give a sub 1. So for this one, we would have a sub n equals the common ratio, which is 0.4, that's the first term. The common ratio is 8, sorry. And then it would be times a sub n minus 1, and a sub 1 is 0.4. Okay. And then last problem, write the geometric sequence using function notation. And so what that means is they want us to write this in exponential form. So in other words, f of x equals a times b to the x power. So if we generate this sequence, the first term is 7, and then this is a recursive definition. It says take the previous term times 3. So the next term would be 21, 63, 189, 567, and so on. So the common ratio is 3. The first term is 7. And to write that in exponential form, a, remember, stands for the first term. So f of x equals 7 times b to the x. And then we plug in a point, okay? When we number these terms, this 7 is actually 0. This is 1, 2, 3, 4, and so on. Okay? And so to write this, we would need to plug in sorry, having dog troubles here. Last problem. Hold on, Polly. We would plug in 21 for the y value and 7 times b to the first for the x value. And so b is 3. So to write this as an exponential function, we would write, don't do that. To write this as an exponential function, we would write f of x equals 7 times 3 to the x. And that is it as an exponential, in exponential form rather than in recursive or explicit form. Okay? The main focus is going to be, can you write the explicit formula? Can you write the recursive formula? And can you recognize that these geometric sequences are, in fact, exponential? Okay? So that is that.